Hey folks, this is Dr. K, and I'm going to kind of go through the start of implementing this car interface, and if there's time, I will make a test case for this, okay, and talk about that a little bit. But this is just a very initial video, so we'll just have to see how it goes. Things will almost certainly be tweaked and modified. Okay. Okay. So this is the car interface, and as you can see, IntelliJ is telling me it is never used, and that's correct. I'm going to use it in a moment. And an interface is basically just a collection of methods that it's used to ensure that when you create a Java class, then it has all these methods that are in the interface. So I've got my car interface here. I've got a start method, I got a stop method, and this is often where we talk about what these methods do here. These are not Java comments. These are just basic comments. Like I've got a start and a stop method. When you start and stop the car, you can start and stop the car. The car has to be in park before you stop it, and you must be in your car before you start or stop it. Now, the one thing to notice here is, unlike other classes, this doesn't have any instance variables. It doesn't have any fields. Okay, the class that implements this will have instance variables. It will have fields, and it will have a constructor. And interfaces do not have constructors either. Okay, they're just basically guidelines for what the class. Well, they're stricter than guidelines. They're basically method signatures that the classes that implement this interface have to have. Okay, so let's get into it. We've got start and stop methods for the cars. For the car, we got lock doors, unlock doors. We've got and all the doors lock and unlock at the same time. So there's just one button you press to lock all the doors, one button you press to unlock all the doors. Okay. However, we can open and close the doors individually. All right. So you got this car door, and that is an enum type. So let's click on that right here. So we've got an enum type in Java is just a bunch of constants. It can get more complicated than that, but right now just think of it as just a bunch of constants. So a car door can either be the driver door, the passenger door, the rear driver door, or the rear passenger door. So this car has 4 doors on it. Okay, and you can use strings to do this, but you might make a misspelling in a string or something like that. So it's just easier to work with constants. Okay, so let's go back to car. And so we can open and close the individual car doors. And then we got a gear we can change into. We can change the gear of the car. And you see I've got this gear class. That's another enum type. So there's a lot of enum types in this project, okay, because you can see gear. And I've only got 3. I don't have a neutral, park, drive, and reverse. There's only 3 gears to this car. All right. So, and I've also got, while I'm on this, I've got car door, which, these are the 4 different car doors. But I've also got a door state, and the door state is open and closed. Okay, so a door is always going to be either open or closed. The gear, I have park, drive, reverse. Location, I have home, work, gym, store. And this message class here, this is kind of under construction. It is not ready by any means yet. But we'll work on that as the project goes on. So what I'm going to do first is I'm going to take this, I'm going to go to my interface, all right, and notice it says interface car is never used. I wonder if I get one of my options is to implement this interface. Yeah, it is right here, implement interface. So I want to do that. I want to implement this interface, and I want to create a class, and I'm going to call this class my capital car with a capital C. Okay, so this class will implement the interface. That means that it will be sure that it implements each of those methods in that interface, and Java will be able to enforce that. All right, so let's see what happens when we do that. We got a package called MyCar. I'm going to say OK, and it says select the methods to implement. I want to implement all of these methods. All right, and I'm just going to go with the default. And look at this. So it creates a class called MyCar. It implements the interface car, and it overrides all those methods in cars. And it's overriding them, and notice it's putting the curly braces in there. Unlike car itself, I just have the signature of those methods. I don't have the implementation inside of the curly braces. So that's what happens when I go to MyCar. You can see the implementation inside of those curly braces. All right, well, I mean, right now there's no implementation. It's a void method, doesn't really need technically any implementations, but we're going to have to implement that. And we're also going to have to put some instance variables here, and we're going to have to add a constructor here. So let's see, what do I want to do first? Well, let's see what we want to know about a car. We want to be able to stop and start the car, so we're probably going to need an instance variable that tells us whether the car is running, okay, whether it's stopped or start. So I'm just going to create a Boolean here. And let's see, do I want to make this private or public? Normally we're going to try to make fields private. Okay, so I'll do that. I'll make it private. Private. This may change. Private is running. Okay, so if the car is running, whoops, I'm sorry. This is an instance variable. Okay, and what other methods do I have? Let me go back to the interface. I have start stop, so I need to know if it's running, so I'll make an instance variable to hold that. Now these doors, am I going to make an instance variables for each of the 4 doors? I don't know yet. So here's what I'm going to do. I'm just going to say I'm just going to ask that question. To do, how do I save the state of each of the 4 doors? Well, I'll just say to do. I'll make that a command. Save the state of each of the 4 doors, the state, and I'll just put like open, closed. So part of this is, I haven't created this yet. I haven't finished this project yet, but I do want to kind of give you an idea of the thought processes that you're going to have to go through to figure out how to create these projects, because you're going to need to create your own instance variables, whatever they are. All right. So start and stop. So let's do start and stop, actually. So start, I've got a push button car, so let's, if I start the car, how does the state of the car change? And remember that the state of the car is basically its instance variables and their values. So right now I only have one instance variable, but because it's relevant to start and stop, that's all I need right now. So I'm going to say, okay, so basically is running equals true. When I start the car, I want to make sure it's running. All right, so there's another thing. If you look at these methods like start the car, you can start and stop the car. The car has to be in park before you start it, before you stop it, I'm sorry. You must be in your car before you can start or stop. So I must be in the car before I can start it. Okay, so let's try to figure out some of this logic. All right, so let's look at the implementation, my car. And this is running here. This is going to be what we do if, you know, when we get the car, if we have a successful starting of the car. But it sounds like there's a bunch of things we have to check first. So I'm going to go ahead and check that. It says we have to be in the car in order to stop it. So how do we check if we're in the car? So I think I want another instance variable, private, I think there's going to be a lot of booleans in here, called hasDriver. And you are the driver. So I'm the driver of the car. Basically, the person issuing these commands is the driver. So this checks if you are inside or outside the car. Okay, let me word this another way. You are the only driver. Okay, for the purposes of this story, you're the only driver of the car. All right, so if the car has a driver, that means you're inside the car. If a car does not have a driver, that means you're outside the car. It's as simple as that. All right. So I said I'm going to implement starting the car, and I need to be the driver of the car to start it. So if the car has a driver and I'm the only driver, if has driver, then I'm going to start the car. So when I'm starting the car, and what happens when I start the car is I set is running to true. Okay, if the car doesn't have a driver, all right, if a car doesn't have the driver, then I don't want to change the state of the car, because I don't want to start it if it doesn't have a driver. I can't start if it doesn't have. But I want to write a message. Okay, so I'm going to have another instance variable here, and I'm going to say private string current message. Okay. And what that current message is going to be is just going to be like the message in like a text-based adventure game. Okay. If the car does not have a driver, I'm going to say current message, and we'll figure out a way to make these more precise. But for now, I'm going to say you are not in the car. Or I should say, let me do this. You need to be in the car before you can start it. Okay, so that's my message. It's kind of sloppy now. We'll fix those up. But I also want. But think of this again as a text-based adventure game where you type in your command and then it gives you some message. It changes the state, so we're going to change the state of the car, but we're also going to, everything we do, every action we do, pretty much, we're going to write a message to the user, okay? Okay, to the person playing our adventure game or whatever. Okay, so that's going to be the message. So even when we successfully start the car, we put a message. So current message here, I'll put the current message as, just to kind of keep it consistent, I'll put the current message as the last thing I do. So current message equals, you press the button, the start button, and the car turns on. All right, again, doesn't, I'm just putting this as like a placeholder to give you an idea of the fact that we always want a message there. And the other thing I personally like to do, I like to avoid, this is just a personal programming style I have. If I can sometimes avoid if-else statements, I will. So I'm going to rewrite this to avoid if-else statements. Okay, here's how I'm going to do that. I'm going to say there is a case which everything works out the way you want it. Okay, and I'm going to leave that to the end. Okay, so I'm going to turn these if statements into kind of, I call them guards. They're kind of checks if all the necessary conditions hold, so that you can do what you want to do. You can kind of do the default, like start. You expect that to start the car, okay? But there are these things that might be occurring that prevent you from starting the car. So I'm going to do this. If car doesn't have a driver, then what I'm going to do is, then what I'm going to do is this. I'm going to set the current message to this. And then I'm going to return. Okay, so what this return statement allows me to do is it allows me to just kind of say, okay, I'm not changing anything. I'm not changing the state of the car. I'm not changing the state of the story or the game. I'm just returning with no state changes. And then here, I don't have to ask if the car has a driver, because if the car doesn't have a driver, I've returned already. I've written my message, and I've returned. So I know if I make it to here, if we make it here, the car does have a driver. Or if we make it here, I am driving the car. Another way to think of it. Okay, so the car does have a driver. And then I don't need this else statement anymore. And to me, when I do things this way, it just makes it a little bit more readable, in my opinion. So if we make it here, the car does have a driver. And actually, when I clean this up, you just go to Code and reformat code, and it fixes your indentation. Okay, so I'm in the car. If I make it here, I'm in the car, because if I don't make it there, I've returned with a message. And I set is running to true, and then I set you press the start button, and the car turns on. All right, so that's kind of the first thing. So we're going to need messages for every possibility here. This is part of the challenge, part of the project. And sometimes your method will change the state of the car, okay? Sometimes it will not, okay? But regardless, we're going to need messages for both cases. Okay, so stop is similar, and lock doors is going to lock all the doors for simplicity. Unlock doors, so you lock all the doors or you unlock all the doors. There's never a case where one door is locked and another door is unlocked, just for simplicity. And then, but individual car doors you can open and close. Okay. So yeah, this is basically it. I will add more information as we go along. Let's see. But I did add some text here to give you an idea of these. I will flush this out. You can open or close a specific door. The door has to be unlocked before you can open it. And like I said, we'll change those messages so they're more fixed across everybody. So everybody will have the same messages. But for now, you can put in messages that you think make sense to you as placeholders. Now, suppose I need to test some of these things. Okay, so this is the interface. When you test a class, you're going to test a concrete class, a class that has an implementation. All right, that's always the way you do it. You have to, because you're going to be testing a particular object of that class, so that class has to have a constructor. Which, by the way, just reminded me, I don't think I have a constructor here yet. Okay, so I have some fields. I want to put the fields first. And then I want to put my constructor. Okay, so let's create a constructor, and I'm going to do this with IntelliJ, with generate. And I'm going to generate a constructor here. And I want I don't think I need any of these actually. These fields, you can set parameters to your constructor that set these fields, but I want to have I don't want to do this because I want to have specific values for these two fields, is running and has driver. So I'm going to do that now. I'm just going to create this constructor manually. I'm not going to use IntelliJ to do that, but it's nice to know you can use IntelliJ to do that. So I'm going to say public MyCar. So there's a constructor, and it's going to be a no argument constructor. It's not going to take any arguments. And I'm going to set the current message to the empty string, okay? Because I don't want it to have a message initially. I'm going to set is running to false. I want the car to be off initially when the game starts. And I'm going to set has driver to false also. So I want the player of this. I'll just call it a game. You can call it a story. I want the player of the game, the reader of the story, they're the same thing, to be outside the car initially. And actually, I'm going to do one more thing. I'm going to have I'm going to put the current location here. Actually, I'm going to put a couple more things here that I think are obvious. So private location, remember that's an enum type. Private location, I'll just say current location. And again, if you want to name these something else, if that name makes sense, then do it. But don't name it something random. Name these fields something that makes sense. And you can use these same names if you like. Let's see. Current location is running, has driver, and I think. And then I might need something. I will need something to save the state of the doors, and then private gear. I want it to tell me what gear I'm in. Whoops. And then I could set these right here when I declare them, but I like to set things in the constructor. That just makes sure, that just reminds me to do things consistently, because sometimes you have to set something in the constructor. You cannot set it right here. But my current message is this, and then I'll use the same order. Current location, I'm going to set to home. And then the way I do that with enum types, I just put location, and then it's giving me options. So I want my current location to be home. That's what's nice about having these enum types. The IDE like IntelliJ can then say, oh, this is an enum type, so they must be looking for one of these 4 values, something like that, which is very nice. And then is running is false, has driver is false. That means you're outside the car. And then the gear, I'll just skip the doors right now because I don't know how I'm going to save their state. And then the doors, the gear, I want to say gear equals gear. Park seems to be, if the car is off, it should be in park, okay? It should not be in drive or in reverse. Okay. So let's see. Let me do stop, okay? Let me do stop just so I can have a couple of things here a couple of methods here to look at. So before I can stop the car, and you stop the car by pressing the start stop button. Okay, and I assume it's going to be similar to park, but what do I need to check if I'm stopping the car? The car should be in park, actually, so the gear should be set to park. And I should be in the car. I don't want to do this where I'm stopping the car remotely. So I'm going to say this will be the same thing, or a very similar thing. I'm going to do this check. Paste that in here. And I'm going to say if the car does not have a driver, I want to say you need to be in the car before you can stop it. And here... Oh, I just thought of another check. These are our already checks. We're going to have a lot of already checks. So if the car... Let's do this for running first. So I'm going to put my already checks at the beginning. So if the car is running... then I want to say current message the car is already running. Okay. And then return. Now, I typically don't like putting two things on the same line, but it's just going to make things easier to read for me, so I will do that. I know when I format this code, this will go to, this will go to another line. But so if the car is running, then I'm going to say the car is already running, and I'm going to return. If the car doesn't have a driver, I'm going to say you need to be in the car before you can start it, and I'm going to return. Okay. And if I pass those checks, then I know the car is stopped, and the car does have a driver. Okay, so if I make it here, the car is stopped and it does have a driver, because if the car was running, I would have returned already. If the car did not have a driver, I already would returned already from line 26. Okay, so I'm going to say, okay, I'm going to make sure the car is running, and then I'm going to say press the start button, the car turns on. Okay, that all looks good to me. Now, what if I want to stop the car? Are there any conditions if I want to stop the car? Yes, I have to be in the car, and I am going to check if it's already stopped. If not is running, that means the car is already stopped. I'm going to say that the current message is the car is already stopped. Okay, and I'm going to return. Whoops, I gotta put a semicolon after there. And then I want to say if the car doesn't have a driver, but I want to say one more thing. If I want to stop the car, I want to make sure that the car is in park. Okay? So I'm going to check that too. I'm going to say, oops, if gear does not equal gear dot park, okay, I'm going to say the car needs to be in park before you can turn it off. And then return. And looks like I'm getting an error here. So I need to insert a semicolon after return. This doesn't seem to make sense to me. I want to see what happens. Yeah, that will give me another error. So it doesn't like something. I think, let me just make sure. So I have a open brace there. So I say if the gear is not gear dot park, okay, then set the current message to the car needs to be in park before you can turn it off, and I've got a semicolon there, and then I've got a return statement with a semicolon there. Okay, and now it's not giving me an error. Okay, so I think I must have already fixed that somehow. And here it says if the car does not have a driver, you need to be in the car before you can stop it. Okay, that's fine. And then I can return. And then if all of this has, if I get to line 46, then that means the car is running. It is in park. I am in the car. And yeah, the car is running, it's in park, and I'm in the car. So I can stop it. So therefore, I'm going to say set is running to false. And then return. And it's probably saying this return statement is unnecessary since it's the last statement of a void method. That's fine. I'll listen to that. And now if I format this, it's going to move these return statements down. But now I'm, that's fine with me. Reformat code. Yeah, so it didn't like these return statements being on the same line as this assignment statement, which is fine. Yeah, it shouldn't really be, but I just put it there temporarily because sometimes it's easier for me to read when I'm just creating that. So I think that's pretty much what I want for now. So I think the last thing I'm going to do here is show you how to make a unit test case. And the field has driver may be final. No, I don't want to. A final field means I can't reassign to it. And yeah, maybe I don't reassign to it in the code now. But guess what? I'm going to want to reassign to this. And I'm going to want to reassign to this, and I'm going to want to reassign to this. So I'm going to ignore these warnings because I know that ultimately I want to update the current location, I want to update has driver, and I want to update gear. All right. So now what I'm going to do is I'm going to go to my class, and I'm going to right-click on this, and I'm going to generate a test case. Okay. And remember, I've already got this this test folder, and it's already marked as a test source directory. Okay. So my test case should go into this test folder. It should create a package called MyCar inside this test folder, and it should create a class named MyCarTest. So let's see if it does that. Okay, where did I see that? Generate right here. Generate test. And it's asking me if I want JUnit 5. No, because WebCat requires JUnit 4, so I'm going to choose JUnit 4. It says JUnit 4 library not found in the module, so I'm going to go ahead and fix that. And it's giving me, do you want this, latest JUnit 4 package? Yes, I want it. Okay. And do you want to generate methods for all of these different methods? Do I want to generate test methods for all of these different methods in the class? I don't know. Maybe as a reminder, I'll just click all of these. Can I select all of them with one click? Doesn't look like it. All right, this other thing I'm going to click I think is important. I do want a setup method, a setup/before method. So basically, that kind of gives me a state of the car to work with. All right. So when you're writing a test case for a specific class, the first thing you want to do typically is you want to create a field that that is an object of this class under test. So I'm going to create a field named private type MyCar, and I'm going to call it MyCar. All right. And notice IntelliJ is kind of giving me a lot of hints here, and I'm just accepting them, which is fantastic. Now, I'm not going to give this a value. Okay, this is a field. I'm not going to give this a value. But in my setup method, that is kind of like the equivalent of, that is where you initialize your fields. So in a normal class, you normally initialize your fields in the constructor. In a test class, you normally initialize your fields in the setup method. So I'm going to say MyCar equals new MyCar. Yeah, and it's a no argument constructor. It's the only constructor I have. So fantastic. So I'm going to just go ahead and write a test case for one of these methods. Okay. And I'm going to do that. I'm going to pause here and do that in the next video. Okay. That's it for this video, and we'll see you in the next one. But this should be enough to get you started.